When I talk about AI, I will not differentiate between all the different techniques out there. I know there is a lot of differentiation needed, but for the simplicity of this presentation, I keep it just under the umbrella term artificial intelligence. And I start with a social theorist, Amin Azehi, who is at the LMU University in Munich. He wrote a book translated in English called Patterns, and in that book he describes his theory of digitalization. And looking into social theory and then looking at digitalization, you kind of have a different perspective on what we actually are doing. And one of the perspectives that he gave me is made it quite simple to understand what digitalization always is, because he called it the duplication of the world through data. And when we duplicate the world through data, we all know that for weather forecasting, we have been doing this since a while. And the more data we have, the more compute power we have, the better the weather predictions are. And we can look more into the future. And we're starting to create so-called digital twins. We're all familiar with that. And we all know that the weather prediction now and 20 years or 30 years ago is quite different and way more accurate. But sometimes we duplicate also the world through data. This is from the Tesla factory, where they are duplicating the world through data to create so-called edge cases. So they are creating synthetic worlds that are helping the cameras to understand the world around it. And as they don't always have these edge cases in the real world, they create these worlds. So they're duplicating the world through data in a synthetic model. We all know this virus that kept us busy during the last few years. It's also duplication of that world through data. It's the COVID virus, and we have been doing that in biology. We have been using data and trying to create models to predict behavior, or in order to see the effectiveness of therapy. So we have been doing this since a while, and we are using machine learning in the field of radiology, and this is from Siemens Healthineers, where they are using CT images to recreate the patient's heart prior to surgery, so the patient or the surgeon can already kind of have more insights into the heart that he's going to perform the surgery on. Everybody has heard most probably of AlphaFold, which is a duplication of the proteome, of the human proteome, which has been published as an open source database. That's also a duplication of the world through data. And we're starting to see more and more of these duplications. But it's quite easy when we talk about data and AI to look at this as a very abstract thing. But as we talk about medicine and we talk about human life that is connected to medicine, I'm just going to show you a different world of a different duplication. So mostly we duplicate the world through data because we want to solve a problem. That's how I worked 20 years. We always looked at a problem and started to build solutions. This is a video that comes from South Korea, where there was a television show. It's quite provocative, where people can come and they duplicate somebody who has died in your life, and they duplicate that person that is diseased into a virtual reality world, so that person that lost her loved one can reconnect. And this is a sequence from a mother that lost her daughter during a car accident, and suddenly the daughter was ripped out of her life. And I'm just gonna show what data and algorithms can do.
나는 엄마 많이 보고 싶었어. 엄마 나연이 보고 싶었어. 나연이 잘 있지?
And I believe it here because I cannot watch this already 150 times, and every time I really get goosebumps, and it's ethically very questionable what they are doing. But I wanted to give you that feeling because this is also data and algorithms, and this is not just about data and machine learning anymore. This is about human integrity. This goes way beyond what actually we normally think about machine learning and data. And during my research for finding Hippo AI, I went into very different theories, and one of the persons that influenced me was Luciano Florido, who is a scholar at Oxford, and he talked about the informational nature of the personal identity. And it's quite interesting when you read his work that as we are digitizing, we are not only a biological self anymore or identity, we also have an informational identity. And these two worlds are starting to interconnect. Like your informational identity is that what you do online and defines your character or defines your person. And what scared me a lot when I saw this survey from Razorfish last year, where they did a survey on US citizens, this is a consumer survey, that when they asked people, where do you feel more yourself? That the Generation Z feels more themselves in that informational world, like in the online world where perhaps you don't have human rights, but only are committed to the terms and conditions of the platforms that you use. And that is quite changing, because like if you see younger people that are feeling more themselves, that mean that their informational self is defining their identity more than their biological self. And this has a lot of consequences, because most of these algorithms that are steering that world, like the recommendation algorithms of social media, of TikTok and other platforms, are black boxes. We don't know why we are seeing the things we are seeing. And that's quite riskful, because it allows people to manipulate and use that power. And we are replacing human rights and fundamental rights in that offline world to terms and conditions in that online world. And that is nice when you talk about things like a Gucci bag that you can duplicate through data in the online world, and that Gucci can sell for a higher price than the real bag. So there was a case where this was really selling on Roblox bags that had a higher price than the real bag. It's quite sustainable. But if you talk about human life, then we need to talk about the duplication of yourself, of the self through data, and what is then the price we will pay for accessing our informational self. Like if that is the case, that we are identifying ourselves through the informational self, that is an online identity that is defined on a platform, then we need to talk about things like ownership, about rights, about all the things that we actually manage to control in the offline world. And these things are happening in a very fast speed at the moment, as we are in the era of generative AI, as you all probably heard with ChatGPT, but also DALL-E and others. We are duplicating not only a single identity, we are now starting to remix these things into very new concepts. And as I mentioned before, we then need to talk about ownership. And this is, for example, a beautiful dance from Dorothea, who most probably practiced for a very long time to do this. And then there was Glenn Marshall, who recently used diffusion models to recreate something new out of the dance that he found on YouTube. Then later, the new Glenn Marshall won all these prizes, and then it boosted the discussion on who actually owns this. Because if that Dorothea was taking probably years to do this dance, and then suddenly Glenn Marshall takes a few days to create and recreate and remix this content, then who owns the rights? Who owns the ownership of that new creation? And this is the most vivid discussion. We have a lot of class action lawsuits in the US that we see. There was one from Getty Images to Stable Diffusion, where they are suing Stable Diffusion, which is Stability AI, which is the organization that created Stable Diffusion, which is a diffusion model, for $1.8 trillion. So there's a huge battle going on who profits actually from this remixing from data. And there was a very important case that the FTC in the US, they declined, because there was here the first person that tried to create copyrights on a book that she wrote, which was 100% generated by AI. The text, the images, the children's story, the images. And the FTC declined copyright for her because it said, like, only humans can create, and an AI or a machine is not something that can create. And that is very, for me, hopeful. Some people look at this differently, because if you then think about medicine, who then owns the generated proteins in the future that we generate through text prompting, and then instead of an image, we create a new protein, which is something people are working on. Can we still then patent these things or protect those things if these are just abstracts of already available data and duplications of that world? So when we then talk about medicine, we need to start talking about what kind of duplication do we need? Because at the moment I feel that the whole duplication is driven by one vision of the future, which is mostly a vision that comes from a center close to San Francisco, where there's a huge speed and drive to create or use the technology, but it doesn't really always connect to the values. And I think everybody's now aware what social media did to our society. Like a lot of people don't want to really talk or reflect on this, but the social fabric of our society changed through recommendation algorithms, and the mental health of children completely got destroyed by these tools. So I think when we are going to apply now very more powerful AI models, we need to start thinking what the effects are and how we're going to implement that in something as important as medicine. And I'm a European. I was born and raised in Belgium, but I moved around in Europe, and I worked for as well a European a software company and IBM. And I worked a lot in the US as well in the healthcare system. And then I started to realize that these systems are very different. They have very different values, and they are very different norms and principles. Like in Europe, it's quite strongly based on a social market economy and not on a laissez-faire capitalistic way. The norm in Europe is much more about creating solidarity systems. And in the US, it's very competition-driven. I think everybody understands these differences. So me as a European citizen, if I can create a duplication of the world and I can influence it, I want to duplicate the world in my socio-cultural context, the world that I grew up in, not a world that has very deep different values when it comes to that. And people then tell me like, yeah, can all be solved. And it's like these values are deeply embedded in society. And I'm reading a lot of science fiction books. I'm a huge sci-fi fan, as it's supposed to be for a nerd. And Altered Carbon was a series that is 250 years about the future, where everything is solved. Like you can plug in your consciousness into new bodies. You can fly around with cars. You have 3,000 meters high skyscrapers. And then there is this hospital scene where he comes with a flying car into the hospital. So you can fly with cars. And he comes with his bleeding to death girlfriend at the emergency care. He puts then the hand to identify his wife or girlfriend, and he doesn't get access. And when I saw this, something was like, okay, we can fly with cars, we solved everything, but access to healthcare is so deeply embedded that it's part of that society. And then when you see surgery, there is no human involved, it's only robots. And then I said, like, well, this can probably be a very realistic scenario, because we have seen that sort of duplication when we see what actually happened in the pharma world, where we started to create assets. And I don't know if people are familiar with assets. It's like we all know assets as a tangible asset, a house, and it can increase price. But intangible assets in economics is something that where you turn knowledge into an economical good. And the assetization is something that is happening through data and machine learning. So what we are doing is that we use healthcare data, we apply mathematics or algebra, and AI models to that. We train that model, and then we start protecting these models with so-called trade secrets. The trade secrets are sort of political, legal, economical protection. So the owner of the asset can kind of define the price. And trade secrets, compared to patents, are very different, because patents can be given and are published openly. When you apply for a patent, you need to describe what your patent is about, so everybody can view what your patent is about. But with trade secrets, it is unlimited. Like you can have unlimited protection on trade secrets, and you don't have to disclose anything. And there are numbers of cases where AI models have put postal workers in the UK to jail based on algorithmic decisions, where it took 7 years to prove that these algorithms were wrong, and these people spent 7 years in an English jail. Then we had in the US similar situations where people took a breathalyzer test from Draeger Medical, and they could not prove, even though they said, like, I haven't drunk anything, but they could not prove in front of court that these algorithms were wrong because these algorithms were protected by trade secrets. And it took them 8 years to get somehow a sort of entrance to show that these algorithms were taking wrong decisions. So if you then connect this to other disciplines, if we are living in a world where everybody talks about the technical black box, but where we are confronted with legal black boxes, where we don't get access to training data, where we don't get access to the methods, where we don't get access to the ground truth, then this can definitely change. And there is a difference between assets and commodities. Like a commodity is that what we call, if I use an AI service and I do a so-called application program interface, which is a web service transaction, then there is a certain price. But with assets, that is purely something that is driven by financial markets, where you protect these assets and then you can define the value based on future earnings. It's not a real value. And we have seen this, I think everybody's familiar with biotech and pharma, how pharma doesn't really do or invest a lot in R&D anymore, but really became an institution where biotech is leading these in initial investments, and then they are protected and become an asset that can be traded on the financial markets with very high returns. This is happening in the digital health space, exactly the same. There was a company, for example, a startup, Flatiron, that was founded in 2013. And all they did was developing, they created a very good solution for oncologists, like an electronic health record, were really well designed, really closely worked together with oncologists to define and create the best user experience and embed it in their workflow. And it was for free to use. They got 20 million patient records. They didn't have a business model, they didn't have any earnings, but then still it was Roche, after only 5 years, acquiring that company for 2.1 billion. So there's like 2 million patient records acquiring and shifting into, as an asset, into, and it was a financial transaction. So like if you invest 300 million as an investor and you get only 3 years later a return, that is a sevenfold. That is a quite good investment in that sense. And as Jennifer Hinkle, a person that I work with, described it in Stat News this year, she said, like, Roche bought Flatiron. There is 1.9 billion here mentioned, but she said, like, based on the projected future success of the business model. So what we see is these transactions are always based on the future. So what we do actually is taking a mortgage on the value of these inventions. The price then, as we saw with altered carbon, where the surgery is not accessible, and people think, well, that's an algorithm, it's a robot, it can be cheap, everybody gets access because technology is always following Moore's law and gets cheaper. No, that's not true, because if you create assets, you can increase the price when demand increases. It's exactly doing the opposite when with commodities, and that's what you saw in the US when we talk about insulin prices. I think everybody's familiar with this case where the price of insulin, which is patent protected since 100 years, increased with 1,200% during the last 2 decades. Now, the last 2 years under pressure, there has been a change, but it didn't avoid that last year. It's not only because of the lack of insulin, but last year in the US, 100,000 people died of a disease such as diabetes. There's a lot of things involved, like lifestyle, but access to insulin is challenging for a lot of people in the US. That's why you also now have an open source insulin project where people are recreating open source hardware to create open source insulin. And I think the problem is not that these companies are evil in that sense, but what actually happens is that there is this, in the financial markets, there is this really strong push for constant growth. And this is not growth in terms of a company, but this is growth on profit. So if you take 10% profit in that year, that profit needs to grow in total. And that means that shareholder value always will increase. And I think that's the reason why we saw the price increases in insulin, because there is an owner or somebody that increases the price. And then you have hedge funds and private equity that drives that price. So there was always this discussion about, well, the R&D costs are high, but that is not that the case anymore. The biggest extraction of value is really within the financial markets in that sense. And that means that we are perhaps heading, if we are selling these companies today for 2.1 billion, where there is no business model and it's based on future projected earnings, that perhaps when we duplicate this world, we are entering in a world where, and I take the concept of the philosopher from Germany, Jürgen Habermas, who talked about the public sphere and the private sphere, and that private sphere is now digital. So what we're actually doing is, when we duplicate that world through data, is that we are starting to privatize goods that never were actually privatized. And this is a one-way street. This is only going into one direction. So if you take health data out of a health record and we shift it into a private company or a startup, and they don't give data back because that's the way how their business models work, we see then an asymmetry between the public sphere and the private sphere. And that's what we call extractive AI. So it's really extracting social value out of that data. Data is leading or is shifting and transgressing to this private sphere. And this is the concept of spheres. And this will create new asymmetries, new power asymmetries. And this is just in healthcare, just starting this model. And extractive AI is also something that is now with generative AI, people, I think, who use ChatGPT? Most probably everyone, or raise their hand when you use ChatGPT. Yeah, half. Yeah. So the people that worked at Samsung used ChatGPT as well, and then they learned how extractive it is, because they were uploading chip designs and asking them to report and summarize things, until then somebody else used that system and then got the really high confidential chip designs, and they were suddenly public knowledge. So that's how extractive it is. It starts learning and it takes data, and there's quite a lot of privacy issues related to that. And I know from an insider that German insurance companies are as well using ChatGPT to scan contracts and all these things because it accelerates work. It's an amazing tool, but if it's extractive and then that knowledge can be used for different purposes, it is quite problematic. And then if we shift everything to the private sphere, we then need to ask the question how we are going to get that social value out of the data. Because not everyone shares the same interest to get access or to create solutions out of the data, because depending on what you can see in the data and how your business model and what your purpose and what your shareholder value model is, you're going to ask different questions what you can do with the data. So there is this danger that perhaps certain solutions or therapies are not even made visible, because the data asymmetries are just there and protected by power asymmetries, protected by trade secrets, as I mentioned before. So how do we solve this? Because I think everybody can relate that this problem is not the kind of future you as scientists and medical doctors want, because you are still the owners and the creators of medical knowledge. You are a scientist. And I sometimes provocatively compare physicians today as the pharmacists in the end of the 19th century, where the pharmacists used to be the producers of knowledge and their own goods and became salesmen of large big pharma companies, because then we saw the industrialization of pharmaceuticals. Now we are seeing the industrialization of medical knowledge. And if medical knowledge gets industrialized, you will all become a salesperson or an applier for knowledge, but not the creator. And I've been attending quite a lot of AI conferences in the US prior to COVID, and there was already this debate that the private industry has more data, more compute power, and they cannot compete with public research against the research collaborations between these universities. So I think we need to define different versions, and that's what kept me busy. I don't know why I started this, but I said, I saw that problem where nobody kind of talked about this, or there was an elephant in the room. And there are different approaches to look at data, for example. You can see data as a common good. And as Paul mentioned, there is a difference between a common good. We had the conversation yesterday, and a public good. Because a common good is owned by communities and the people in that sense. And a public good is owned by a government and made accessible to the people, which is a very different thing, because a public good can be connected to political or geopolitical interests, but a common good cannot. there is a reason why there is still the internet in Iran, because it's all based on open source. If that would have been something that was not a common good in that sense, it would not have been open sourced, then boycotts and other regulations would have been able to control access to that sort of technology. So there is a difference between these two concepts, and what I mentioned all before, is when we see data as capital, although you cannot from a legal perspective own data, but you can create IP around databases, you can use trade secrets as we heard before, then this is what we then call data extravism, or as Nick Coldry, a professor from London School of Economics that I work with and is an advisor for us, he calls it data colonialism, where capital defines on the capacity to extract value, and the owner is then in sort of the startup, but then perhaps also the shareholder in that sense. And they create over time then a model that is related to what we saw in pharmaceutical, a model that creates, if you have an asset, you're going to start creating artificial scarcity in order to increase the price, because it's not a commodity. There is this other concept as Web 3.0, as we call it, where people tell we need to tokenize data, and then we all become owners of our own data. That is a very nice concept, but is also based on the same narrative that data equals capital. So that means that capital, our data concentrations will always follow capital concentrations. That will lead to asymmetries, will lead to the same problem. And the hope that I see with a lot of young people is like, I want to get money from my data. I say, well, I don't think that's going to help, because if everybody starts selling their data, the additional R&D cost is just going to be added to the bill, and then we're going to, as a society, pay for the total cost of the developments. And I think by receiving $500 for your data, and now seeing the price of gene therapies, which have reached a price of $3 million, I don't think that's going to really help to get more access or increased access to healthcare. Then there is the approach that the European Union is using, that's regulating everything. So it's creating rules and creating a mixed model where we still see competition, but it's also based on the idea that data has economical value. And in Europe, there are now 6 new acts being defined that are going to, the AI Act is now going through the Parliament. There is a Data Governance Act, there is the Digital Markets Act, the Digital Service Act, the Data Act, the AI Act, and the Cyber Resilience Act. And then they talk about so-called European data spaces. There is this trend that Europe wants to protect data. There is also a trend to deglobalize and not give, for example, Chinese researchers access to European data, and vice versa. So what you see, this is this trend of creating spheres as well that are based on political narratives. But I think none of these concepts I truly believe are going to change anything, because when I look at the Data Governance Act and the AI Act, then I see that within that European health data space, data can be owned and protected by IP. So that means that we have a common data space, but still capital allows to create these asymmetries. And yesterday, Cecilia Bonfeld-Dahl published a letter to Ursula von der Leyen with this weird sentence that 90% of the European companies' data is unstructured and not yet protected by IP. And I think that is really wrong mentioning this, but this is because of the lobby interest of certain organizations. My approach is a very different one. I come from the software world, and I spent 20 years in SAP and IBM, and these are software companies. And my world started with in the early 2000s and 90s, where IBM was fighting or competing with Microsoft, and Microsoft suddenly decided to make everything proprietary, closed software, everything with their own standards. I think some people can still remember the battle for open standards versus Microsoft standards. And at the end, 20 years later, open source won that battle, because I think nothing is more powerful than the power of human collaboration based on shared values and principles. And what actually happened with, we all know Linux and we all know the internet, is that people started to collaborate in creating common goods. And so I asked myself the question, can we build a concept that does that exactly? And learning a lot about history, I found that actually we already had a discussion, and it was 25 years ago when the Human Genome Project was an open source collaborative project where many organizations started on a daily basis sharing their findings, while at the same time there was a company called Celera in the US, a biotech company, that was already valued on the stock exchange based on future projections for a 2-digit billion value. And they were trying to patent the human genome. So there was a battle between patenting the human genome versus making it open. And I never thought that I was going to give this person stage, Tony Blair.
We, all of us, share a duty to ensure that the common property of the human genome is used freely for the common good of the whole human race.
So if you can say something about his policies, perhaps this is the policy that I would support. And it's based on the work of John Stolston, who is a Nobel Prize laureate that was part of the Human Genome Project that pushed to make the human genome an open source project and a common good. And the biggest contender that I always have is when I come with open source, is like, how are we going to earn money? How are we going to see investments? Well, I digged into that, and the openness of the human genome created nearly $1 trillion on economical value creation. And I think that's way higher than anything what would have happened if we would have patented the human genome. Patenting the human genome would have been something similar as telling to Gutenberg when he invented the printing press to patent the alphabet. Well, we know that if you would have patented the printed alphabet, that publishing a book would be very costly, because for each letter you would have paid licenses, and probably we would still in Europe have been buying letter of indulgences, and we probably would have never seen the European or Western Enlightenment in that sense, and the open science and open knowledge movement. What people forget as well is that the internet, as we know it, is, as I mentioned before, an open source project where CERN and the scientists, which are really Professor Hoogland, who was leading CERN at the time, because everybody talks about Tim Berners-Lee, but it was actually the person who released the patents and who released the IP that created the open access of the internet that we should celebrate. And based on that, we created on all this experience a new concept, which is what we call regenerative AI. And this comes very much about these current discussion about sustainable economies and mostly focusing on ecology. But how I see ecology or healthcare as a sort of an ecosystem, which is very similar as nature. When you extract too much, you create imbalances. You will create out of these imbalances disruption perhaps in society. So how do we balance this, and how do we, between the public sphere and the private sphere, shift data? And I'm working with Professor Barbara Preinsack from the University of Vienna, and she published quite a lot on the concept of what we call data solidarity, like creating concepts where data is equally shared. And you can only do this within a closed ecosystem, because if I'm the one only sharing and the other one is not sharing, you can use the game theory and the prisoner dilemma as an exercise. You will lose. You will lose by sharing. That's why none of the companies started sharing, because if there's no common ground and common rules about sharing, then this is not possible. And we try to do the regenerative AI. We're working on licensing models. Licensing models is a copyright, and it's also IP. Open source is also a form of IP. And so what we try to do is to create these systems where, in order to create systems where knowledge is being used as a common good and it's being kept open, where the knowledge production comes from communities instead of from companies, drives this forward. And I must say, starting something like this, you have to be very naive and courageous, but I did base jumping, so I think there was something that related to that, because everybody else is doing the opposite. And 4 years ago, we started like thinking, how do we do this actually? And what I learned is during the COVID crisis, there was so much open source and there was so much openness because we all had a shared enemy. And when you have a shared enemy, you start to collaborate. And I think the world as a whole will only collaborate when Death Star from Star Trek will destroy the world. But for a lot of people now, ChatGPT became Death Star. And that's quite interesting because ChatGPT is owned by OpenAI, which has nothing to do with openness. They released their GPT-4 model with a publication, a scientific publication for 94 pages. But we don't know which training data it's trained on. We don't know anything. They decided to close everything and protect it by trade secrets. And that's quite dangerous because when they released GPT-4, I asked then ChatGPT, what is so difficult against, what is the danger then from open science? Why didn't you publish these things? And then it answered me, this is a misconception. There are only advantages for open science. There was a huge press conversation on Twitter. There was, I remember that I was nearly the whole night discussing on Twitter because it was a very difficult thing that they published this without disclosing anything. A week later, I asked that same question and I got only disadvantages for open science. And this should be a warning because this is the same system, the same question, and this is exactly the opposite answer. And it serves shareholder value. It serves first their purpose as a company instead of sharing the purpose of building that knowledge. And I think that's why I don't believe that these models can be closed. Power is there to use power, and power will always lead to this asymmetry. So the good thing is that there are many people like me that started to unite based on that shared enemy vision. And last year there was a collaboration called Big Science that published an alternative to GPT-3. It was not that good yet, but it was a bit similar like the Open Genome Project, where 1,000 researchers started to work on a model that is similar to GPT-3. It's a transformer model, and it's called Bloom. I celebrated that because everything was publicly open sourced, open science published. They published a research paper with 1,000 authors, Big Science. I love this. Like 1,000 people collaborating on the same purpose. That's, I think we have in the public research, we have an incentive problem because we don't collaborate well. But if you see what happened here, what we see now through Bloom is that in the last 6 months, I haven't witnessed this in my whole life, so many people started to collaborate on open source alternatives. And we see on a nearly weekly basis new models. This doesn't even count for all the models that are out there. But we see quite a lot of publications of these new models coming out. Like there is an open assistant that is nearly on the same benchmark level in a lot of tests to ChatGPT, which is completely open sourced. And there are open source projects that you cannot use for commercial purpose. Because of the copyright, because some of the data is can only be used in fair principles for research, but not for commercialization. But the lower level is that what we need to do. We need models that we can give to companies, and they can embed it into EPIC or CERN systems, but are not extractive. So when you use it as a physician, that we are seeing systems that allow you to create services within your hospital that are collecting information and creating knowledge that define the better results for your organization. The bad message about this is none, and even ChatGPT, none of these models can be used for medical use. So the reason is, you can do this in consumer markets, but the reason is they are not built on a quality management system. Can do audit trails. You need all the things for certification. And they don't have that. So none of the models can be embedded within a medical product, and that product cannot be certified. Although there is a lot of use and there's a lot of publications, but I've been a product manager in the past, and I think none of the companies that creates medical products will use these systems. And ChatGPT is cloud-based, and that cloud in the US needs to be HIPAA compliant, and I don't think ChatGPT infrastructure is HIPAA compliant. All these things are related to that. And then last week I celebrated. I really opened a bottle of champagne because after 4 years of frustration, always being confronted with people that tell me like open source doesn't really work, and my arguments were that open source collaboration will accelerate innovation much faster than any closed model. And my arguments were as well that it is cheaper in that sense. And now last week there was a Google leak. Somebody from Google on that semi-analysis, on a community but semi-analyst published this, said that because of what happened in the last few months, they don't have meat on the bone anymore. They don't have a secret sauce. And they even mentioned that open source companies are doing things for $100 with 13 billion parameters, and where they struggle with 10 million in that sense. So these open source collaboratives and these communities are the best way of competing the darker world, which is going for closed and proprietary. And finally, it's out. People believe me because a Google engineer leaked a document before they didn't believe that this would work. And this is quite promising because, or good that we have, or we see this. Nevertheless, within the European Commission proposals for the new digital acts, the lobbyists were successful in putting 2 amendments in the AI Act. They try to regulate open source code. That means when you are a researcher, you publish your research paper and you publish the code with your research paper, you as a researcher can be made liable for publishing that code. So that's one. Nobody's going to publish code anymore. So we're fighting against that regulation. And then the Cyber Resilience Act, there is a similar trial of forces, probably coming from IP lawyers and investment or finance markets, that they try to do the same because they know that open source will win. But there is a way how to perhaps stop this win when you start regulating open source collaboration. And we need to, like open source implementation should be regulated, which is the post-deployment, but the pre-deployment way of developing this thing should never be regulated. So this is the world that I'm moving in with Hippo AI. Why Hippo? Well, of course, Hippocrates. And when I did my research in the original oath that was translated for ancient Greeks, there was written that physicians should share their knowledge without a fee. And it's like, wow, this is open source embedded within the original Hippocratic oath. So that's why we call it Hippo AI. And what we do is really all the learnings that are managed or that we saw from all these projects. We work with patients. We believe in informational self-determination. We worked with data donation campaigns. We connected humans through communication. We're trying to unite data and we foster. We don't develop ourselves. We foster communities to develop. And at the end, by doing so, I think we can defeat global inequalities, because if you have certainly AI models that are openly available, then even African entrepreneurs can use this model and build their own solutions. This is a bit provocative. You need provocation. We even used Instagram filters when we did our first breast cancer campaign to unite people, create awareness. And through that project, we were able to collect histopathological data for detecting HER2 gene type variants and create a first open source model in that field. And we learned a lot because we made mistakes. We did that project all ourselves with our own resources. That doesn't work. So what we're doing now is really fostering the community. And we started 2 months ago by opening up our community, which is growing quite rapidly. We have 140 data donating organizations signed up. We are seeing from everywhere globally people following that narrative from Hippo AI. Where we have troubles is financing such a foundation. I'm not Steve Jobs, or I'm not Bill Gates, or I'm not somebody who exited his career with $1 billion on his account. So you need to find ways to make a sustainable model. And with a very naivety, I said, like, well, if Doctors Without Borders can get 2 billion on donations a year, I will be able to get donations as well. No, that was not the case. So we need to think differently, but that's good. You learn and you challenge yourself. And as we are talking about regenerative AI, I looked a lot into sustainability concepts. We saw that people were doing carbon offsetting. Like when you fly and when you're an aviation company, you can compensate the imbalances of carbon by buying carbon certificates. And then we said, like, well, that's exactly the same. If you look at the digital sphere and the public sphere, then we see imbalances, like with carbon imbalances as well. So we are rewarding, or we start to reward, and we're working with PricewaterhouseCoopers and others now on a concept that we want to initiate, where we want to donate or give certificates for health data offsetting, just like carbon offsetting. That means that if people contribute, or companies like AstraZeneca, who supported us in our breast cancer project, and they support these sort of endeavors, they get a better ESG score in the financial markets. They become more sustainable. Similar when somebody, if Shell or Exxon would sponsor Hippo AI and they would give us funds for open source projects, they would get a better social scoring on that ESG score. It's a trial. I don't know if it's going to work. We need support, but I think it's the closest trial of what I've been trying to do to make it sustainable. And yes, we can measure this in the same way as pharmaceutical companies using the quality adjusted life years indicator, which is a metric that is out there from already health economics. We are now in a process of finding supporters for creating what we want to do is creating a MedGPT, if you can translate like this, called Hippo 1. We have collected very large data donators, such as the Internet Archive. Bruce DeKale has the same vision as me. He believes in open knowledge and access to knowledge for all as a human right. And the Internet Archive is the second largest data holder after Google. So you need a lot of data to create these models, and he never gave that access to that data to any commercial company. And we are trying to build a model in that sense based on a quality management system with audit trails, with consent, which is quite expensive, where we in each of these hospitals need PhD level researchers. But once we will publish this model and we achieve to publish this model, the industry can use it, retrain it, and we are moving away from extractive AI to regenerative AI, and we donate this to society as a Hippo AI Foundation, which is our purpose. How does this fit into the landscape? Well, you have the closed systems like Siemens Healthineers doing MRIs and CTs and PAC systems, which are all proprietary. Now you have OpenAI creating an ecosystem where they're creating applications with an ecosystem. Or we can do this in an open source model. That is not out there, but it's going to, it's already happening in others. The first thing that we're also building is a platform for physicians and researchers where we give access to data, access to models. We want to create a digital library. And we do this in a sort called a stewardship model where the non-profit and the for-profit are connected with each other. So the profits serve the foundation and we can reinvest these profits for society. That was it. If you want to join, we have a tool called askpaper.ai. It helps researchers it's for free, to use AI for extracting information. And you can also join Discord and our community in joining our mission. So with that said, I would say collaborate or die, being provocative. Again, this is the General Director of the Ministry of Health in Switzerland. There's so many people that want this open world. So my message is, I hope I could convince people here to join us and unite to fight the future inequalities of digital health. Thank you for your attention.